Hi 21A. This is the quiz key for quiz number 1. The first question reads, suppose a train is leaving Davis and its position with respect to time is described by the function p of t is equal to t squared for a short while after leaving the station. The first question is really simple. It says, draw the graph of the train's position with respect to time below. Note the bottom left corner corresponds to 0 seconds and 0 feet, and the grid is 4 seconds by 16 feet. Okay, let's just start out by making a table of points. So if my t value is 0, then my p of t value, or t squared, is 0. When t is 1, p of t is 1 squared, which is just 1. When t is 2, p of t, or t squared, is 2 squared, which is 4. Goes on when t is 3, p of t is 9. And finally, when t is 4, p of t is 16. Okay, now we just need to plot those points and draw our function. So 0, 0, like I said, is in this bottom left corner. And then 1, 1 is up 1 and over 1. 2, then up to 4. 3 up to 9. And finally 4 all the way up to 16. So now if we want to sketch this, it's going to look something like this. This nice quadratic curve. The next question says, what is the average rate of change between t equals 1 and t equals 3? Note this is the slope of the chord line between 1, p of 1, and 2, p of 2. Now notice we kind of gave you a hint, so if I redraw this graph here, and I say that my point 1, p of 1, which is 1, 1, is right here, and this should actually read 3p of 3, because we're asking you between t equals 1 and t equals 3. Then my other point is 3, 9. So let's put that here. So if the function looks something like this, a curve, then the chord line between those points is the line that connects them, like that. And we're saying what is the slope, or the rise over run. So both the formula for the slope and the formula for the average rate of change tells us that this is just p of 3 minus p of 1, the difference in the y values over the difference in the x values, or 3 minus 1. Now that's just 9 minus 1. P of 3 is 9, p of 1 is 1, over 3 minus 1. We simplify, that's 8 over 2, which is just 4. And now we do the exact same thing, but with t equals 1 and t equals 2. P of 2 minus p of 1 over 2 minus 1. P of 2 is 4. P of 1 is 1. The difference between 2 minus 1. So this is just 3 over 1, or 3. Now the last question says, draw the tangent line of p of t at t equals 1. Let's do that first. Now the tangent line is the line that just touches the function at one point. So here you can see I'm drawing a straight line that just touches that 1.11. Now the next question says, how could we estimate the slope of this line? You can describe in words or explain graphically by drawing a picture. Now what we were going for there was that you would notice that the function, if I just sketch it here, and let's say this is the point 1, 1, and here is my tangent line. We're hoping that you would notice that what we did here, we have these chord lines, right? And as the chord lines, as the points got closer and closer to 1, the chord line slope is actually getting closer to the slope of the tangent line there, or the instantaneous rate of change. So the graphical way of answering this question was just to draw some points like this with chord lines and show me that you understand that the slope of the chord line as this point moves towards 1 is getting closer and closer to the slope of the tangent line. A lot of you knew that this just is p of 1 plus h minus p of 1 all over h, and we're looking at this as h goes to 0. That's exactly right too. Notice that this is just the average rate of change between a point 1 plus h, p of 1 plus h, and the point 1, p of 1. And we're looking at that as h goes to 0, so that's as this point is getting closer and closer to our point 1, 1. Now, some of you even notice that this is the limit as h goes to 0, which we now have this notation